Hello and welcome to my fresh start. It's time to actually start making something. I've gone through some tutorials in the Unreal Engine. I've also done a lot of Blender, I guess guides is a way to put it. And so far I've just basically making something from scratch. This is an empty level. I just made a test map right here just so we can test our game mechanics and stuff like that. But the gist is that I want to make a Super Monkey Ball clone. So you know, you have like a physics-based rolling ball, and it's half puzzle, half platformer type thing. Because I don't think we've had a fun version or fun clone of that yet. So starting from scratch, except for this just sphere I made in Blender. I made a sphere even though Unreal Engine has spheres in here, just so I know that my texturing is actually, let me show you. My texturing is where I want it to be. So I have a texture here. It's just green and red texture, so that when going to edit mode, you can see that the quads that are mapped here, they will be mapped to the texture in halves. So I think I can do this. Let me see if I can just do texture. There we go. So our test ball is just gonna have two halves on it, you know, one top, one bottom, and it's a sharp defined line, just so that way we have actually something that looks decent enough for lighting purposes and stuff like that. I just need to figure out how to export this correctly. I'm pretty sure the recommended is FBX. I'm not sure what's all contained in an FBX file, so let's try this out. So hopefully I can just kind of drag and drop this into Unreal. I'm not sure if like the texture will come with it or not. And also I would need to make maybe later on I'll do a normal map so that we can give the sphere the appearance of some surface depth. Or I could maybe like do some sort of bump mapping on that or something like that. But since I'm trying to do a Super Monkey Ball clone, I might and just I don't know, make it look like there's actually two halves to the rolling sphere. Oh, I haven't mentioned my supposed work in progress title for this game is Mega Gecko Ball. I just went and made sure that there was no like trademarks or anything like that, anything weird. But that's just a work in progress title. But I just figured, why not go with a similar name too? I couldn't come up with anything creative, so I think I want to have like a little gecko rolling it in a ball. It's gonna look really, really cheesy, I think, and the concept behind it will be cheesy, but it'll be, I think it'll be funny to see. Let's make a new folder in here. So I already placed a maps folder for our levels, and I will make a what do I want to call it? Just models, I guess. If I can type models, we'll just go with models. Let's see if we can import assets, miscellaneous, sphere halved. Seems to be working so far. So I have all the actually I'm going to turn off engine content so we don't get all the junk, but we do have the starter content in here too, so we can do some basic texturing and material work if need be. I think we're just gonna go with all the defaults. Is it gonna work? Hope it works. I didn't test this before. Sorry if I'm coughing a lot or anything like that. I feel like I'm coming down with a cold. This damn winter always catches me by surprise, and I don't like it. Come on. I wonder why it's taking so long. I wonder if... I don't know what the FBX uses. I don't know if it... because I have applied a... Well, not applied, but I have a modifier, what's it called? A subsurf modifier that subdivides the surface so it smooths the edges out. The view is on 2, but the render is on 6. So I wonder when it exported, it might have used the render, which maybe means that there's a lot of, I guess, polys on this. Maybe that's why it's taking forever. What else can we look at? So I will, later on, I'll show how to use Blender and stuff like that. I've done some basic modeling. Here, let's open up something else I was working on. I was working on a claymore sword. I was kind of basing it off of something like this, where it's just pretty much a straight blade. Going with like a straight crossbar thing. But I'm still learning how to use Blender a lot. There's a lot of stuff that I don't even know how to use at all. Let's see if we can apply a, what's it called? Environment texture, HDR. Do I have it? More loading. That doesn't seem right. This does not seem right at all. Wonder if this will break my computer. We're doing that was a mistake. Don't do that. Do not do that. Hold on. Technical difficulties. All right, come on. The weather outside is frightful. Oh. I'll just put that up. I've got some partial control back over my computer. What's going on? I'm gonna need to close down Blender. Blender is now crashed. Okay. Good. We're gonna resume soon, I would hope. Nope, Blender has not crashed. It is back. I would like it to just stop. Okay. Huh. This is just okay. What's going on here? There are so many things popping up now. Okay. Look at this. Unreal is just going nuts. I have no idea where Blender is. Blender has now crashed. How big is that file? Holy crap. I don't know what this is. I don't need this. I don't have Elgato connected yet. Or at all. I'm just gonna close that out. We don't need that. Oh, look at that. And it's still like reading stuff from the disk. Let me go check. But I think we're back for streaming. YouTube thinks it's not okay, but I think it's okay. I think it's okay. So it's like 100 megs worth of data, which is weird because like you look at the Blender file that has that thing, and it's like, oh, it's like half a meg. No biggie. And then you make a sphere and you export it, and it's just like, oh, ridiculous. And we're still importing it. Okay. I will have to do stuff like this off stream, I think. So I will have to break up modeling streams, I think, from actual development. But that at least means that we can focus on certain things for streams. So that'll be okay. I guess we're back. Oh, I think either the Unreal editor has given up or it worked. There we go. We're in. It imported a material as well. Okay. I'm getting a message log. That says once we get back. All right. No smoothing group information was found. Please make sure to enable the export smoothing groups option, the FBX exporter plugin, before exporting the file. Huh. I don't know completely what that means, but let's just put in a box. So we put in some geometry. I'm gonna put in a 0, 0, 0. It's over here now. It is very dark in here. Let's just close that a bit. Sure, that'll work right. I might take this window out. We don't need that. I'm just gonna bring that out so you don't need to see my content browser. If I bring stuff in, I'll tell you that I'm bringing content over. Anyway, so yes. We have this. Let's just set it to 20 for the Z, and let's just do 1,000 and 1,000. This will basically be our testing playground. but we can't see it. So let's put in some lighting. Skylight. That'll be good. And a directional light, I guess. So there's something. And what's our sky sphere? Okay, now we have something going on here, right? Let's apply our directional light that we just put in. So I know how to do that at the very least. So our skylight, I'm not sure what that does. I just know that we can put that in there. Then we have our directional light, which is like the main light source, I guess. I'm just gonna kind of group these together. So now we have some light on our little playing field. Good. And now we have a nice sky sphere with a basic sky shader, I guess they're called. And that's pretty much all we need to get started. Let me give this something more interesting color, I guess. Wood oak. That doesn't look very wood oaky. Does it already have a texture on it, or am I just crazy? Oh, shaders are compiling. So let's try to throw that. Okay, now I'm going to my content browser. I'm going to try to. There we go. That's loaded in. Throw in that sphere I imported. So it's pretty big. And it's very smooth. Very smooth. Okay. So maybe I don't need to have my render settings up so high on my models. I remember setting a size in Blender for the sphere, but I don't remember it being this big. So let's see if we can add on a material, a texture. Let's try to edit this material. I'm gonna see if I can use that test image texture. So it's very basic. I don't know what that. Oh, they're overlapping. So this is just color. You don't want this. Just delete that. Texture sample, that's what we want. Oh wait. Here we go. So let me I'm gonna go into the content browser and I'm gonna make a new folder for textures. And here we're gonna import that basic texture that I had. I think I put it in here. Yeah. Just a red green basic. So we'll try to use that on our material and see if that works. All right, that's all good. Sweet, red green. Oh, we have to connect it, I guess. Is that how that works? I have no idea. I have no idea. Okay, this is more advanced stuff. Oh, I mean, it kind of worked. It's on the wrong side, but I'm sure there's a way to rotate that maybe. But for now, this is fine. Save as, and we'll just call this like a debug ball. Debug ball material, I guess. Material, put that in content, not in models. Let's rename this to materials, plural. Okay. So in here, we'll do M for material, and we'll call it debug ball. So we'll just have a debug material, and it keeps putting it in a different window. Sweet. So we'll go to here. Oh, it properly is set now. So if we want to search debug, so we set our special material, and it's good. Okay, not bad. So that's basically going to be our character. So I made this in Blender, and now we got the material in there and the texture in there. I'm just going to rename my texture real quick. Excuse me. Or test ready. Okay. All right, so we don't actually need this in here right now. What's going on here? Why does that have material 1? It's just yeah, that's fine. I'm gonna see what it looks like with built lighting. My computer likes to freeze up, I guess. We're doing this. Maybe I should turn off the swarm setup. Hope there's a setting for that, because I don't need that. But the first thing I want to do with this is do like the movement mechanics first. I want to make sure I can get that working. And I want to try to do physics-based movement. I don't want to do any like hacky type of like sliding along the surface or anything like that. I want it to be like a physics platformer, so that you can basically solve puzzles or, you know, problems in the game using physics, you know, that are it's more open to experimentation for the player. So we'll ignore that while that's building the lighting. Let's see if I can turn off that swarm agent stuff. Huh. Guess not. Let me just make sure I was searching all settings. Yep. Okay. Weird. So, is that just going to take forever to build? Huh. Anyways, so we don't need the sphere. I'm going to expand this because this looks kind of small. How do I do this? It's right down here. Is that too big? I think that'll be fine. And now we can add some basic things in here, I think. I could mess around with doing geometry. Let me try to do using static meshes and stuff like that. I'm just gonna make like a little ramp thing over here. Trying to deal with remembering the hotkeys for each program. Like I learned this first and then I learned Blender. So a lot of my Blender hotkey knowledge has like started to seep into the Unreal editor. So just move that up. We're just gonna rotate that. Something like that. And that'll be fine. Let's just copy that. Hold on Alt. I can drag down a new copy. I'm gonna rotate that 90 degrees and move that again. Let's make these a little bit wider. Something like that. Some weird music. Huh. All right, let's add in like a little platform up here. And it's just gonna be like a little raised platform here. Okay. Down. Let's scale that up. Make it a little bit wider. Good. Alright, let's see here. Let's make these different colored. No, where is it? Right here. Basic floor. At least gives it a little gray color so we can see it. It's gonna blend into the background. Let's give it a different color. Let's just go with like grass. Just so that it stands out. What if we do stone? I don't know what I'm doing. I'm not searching the right thing. There we go, stone. And we'll just do hewn stone. So now let's line this up. Are these on the same height? That's 280. This is 280. Okay, let's move this up. Oh, I think. Oh, we gotta move this over. That's what's going on. And how much does this move up by? It moves up by 10. Let's go by 5. That seems fine. Okay, so now we have two little planes. Just so we can see if we can get up there. Do they have a collision? Let's see. Is it really going to take this long to load up? There we go. They do have collision. Okay. Alright, so we have something to test if we can get up like a hill or something like that. And we could test gravity to see how that behaves on an actor. Let's just mess around. Let's put physics on this boy. Just right up here, simulate physics. I'm just gonna basically put him up on this thing and let's drop him on top and see how he rolls. Something like that. Just drag that up and let's see how it goes. A little bouncy. Huh. For my actual levels, I think I'm gonna actually make them as static meshes, meaning that I'm gonna model them so that I don't use these you know, the basic ones, or I don't use like the geometry which you can shape. Yeah, if you don't know, with geometry, it allows you to basically do like some freehand modeling with them. So you go to geometry editing. You can't do this with the basic meshes that they have, only the geometry presets. But you can basically take like vertices, and how do you do this? Did I click on that? Oh, there you go. I just didn't click on it and activate it. So you can basically change vertices, faces. And let's say I want to make a bigger base on this bottom of this, and then I scale it so I can basically make like a quick little shape using just a box, so I don't have to go into like Blender or Maya and do a separate static mesh. But I think I'm gonna actually just do it in Blender. But yeah, it's a pretty flexible tool, but it doesn't have everything that you might want in like a little geometry editing or model editing thing, I guess. But for some like little debug courses or anything like that, sure, it'll be quick and dirty. But I guess now we have that in our level, so we'll just kind of put that off at the side. So let's actually make our pawn, our character's pawn. So let's set an empty pawn out there, and we have to give this a static mesh. Let me just search this. Not quite sure. Oh, there we go. Have I done this correctly? Yeah, okay, so there's the static mesh. I'm just gonna have the static mesh as our root component. So the root component is just a component for an actor, I guess like an object, that holds all the root data for that object. So things like positioning, rotation, and scale, they're going to be based off that root component. So if I just use our ball for this, sphere halved, yeah, if I just use that, all the collision, well, you have to set collision, I think. Yeah, I think this will work, right? I don't think you need to have a separate collision mesh. I mean, you could have a separate collision mesh, but we don't need to. So let's just see. Let's... how do I want to do this? I think I'm gonna simulate physics on this, and So yeah, it has a collision mesh for that static mesh. I'm trying to think. Do I want to have the static mesh as my root component? Do I really want that? Because if we're rotating a lot and we're applying forces to our root component, I'm thinking, is our camera control going to be all whacked out or anything like that? I guess we'll solve that problem if we run into it. I was doing some testing. You might have seen in some past streams where just things were not working well if I was using physics as a root component object, I guess. So on top, or I guess to the side of the static mesh, you want a controller. Do I want a controller? Is that what it's called? No. Movement component, I think it's called. What am I doing? Add component. Movement. Am I just blanking right now? Okay, get rid of that. I might just be crazy right now. Does an empty character have it? Do you have to be a character to have a movement component? Character movement. I think so. Maybe we should be using the character instead then. Now, what kind of movement can I get on this? Movement. Floating pawn movement. Terp 2. I think I will have to make a character so we can get that character movement component. Alright, so let's just delete this. Empty character. We're going to replace this. Or, well, we have to do static mesh. Is this what I want? What's the difference in meshes? I think I'm just gonna overwrite that stuff. No, I cannot, because it's inherited. Ugh. Can I hide the static mesh? Capsule height, capsule radius. I cannot see. Oh, there we go. So I guess we can try to just match this up, maybe. So it looks like 100. It's gonna be our number. So now our capsule is in the shape of a sphere. You can see the outlines, the yellow outlines on there. So now our capsule encapsulates the static mesh. You know what? That's not what I want. I'm just gonna use the mesh, the inherited mesh. I'm just gonna use a skeletal mesh though. I don't like this. And I can't delete this. I'm wondering if I'll have to make my own character. I don't know. Huh. I don't need this. Let's I'm gonna save this for now, and I'm gonna actually open up the template. Let me just save all using this. The template has there's a rolling ball template, and I already have it's a open or a project that I already had. sample rolling. Yes. And so they used a ball and they had a movement component that came with it, and I want to see if they had a character as their ball or not. A lot of stuff to think about, and if you're not just going straight off like a tutorial or something like that, it's kind of hard to keep track of it all and be prepared for all the problems that you might have. But we'll just wait for that new project to load up. Trying to think. I'm trying to think of the actual game design for like levels and stuff like that. Which is something to do while we're waiting for this project to open up. So the levels are going to be pretty short, and they're going to be timed, because this is a Super Monkey Ball clone after all. They should probably be broken up into worlds for, you know, theming purposes and for difficulty purposes. I don't want to do this all. And I was thinking, like, it might be kind of cool to put in like power-up pickups, like maybe like a speed boost that you would activate once, maybe like a jump mechanic, but that's not really in the spirit of a Super Monkey Ball clone. So I'm not confident about that yet. But we can do some drawing. I feel like for a first level, maybe a straight level might work well. I'd want something to at least demonstrate the idea that your character is under the control of physics. So maybe like a bowl at the end. You know, like a bowl at the end like this. And we have the goal in the middle. You know, we have like the goal right here. For the goal, I'm thinking, how can I don't know how to move this. I've never used it before. I think the goal should probably just be like a circle. And like in Super Monkey Ball, their goal, something like that. That's what I'm thinking of. Their goal is shaped is in the shape of a gate. So it's kind of like this, but then it's flat at the bottom, and then it has basically a little kind of like a doorway. So then something like this. Are there hotkeys for this? Insert, edit. I don't know how to do this. Is there an insert shape? I don't know. Anyways, our project has actually loaded up. I've seen the corner of my eye. Yeah, their finish line looks something like this, you know, and you have to break the tape right here in order to beat it. I'm thinking something a little bit kind of easier, just basically a circle. where once you break the surface of the circle, that counts as a complete. So sometimes if, let's say this is a like a side view, and like this is the ground of my level, something like this, I guess, is more appropriate. So if you just roll in like that way, that would represent the kind of idea that they had going on here. But the problem with this idea is that during the game, it's like a very small goal to hit, and sometimes you're moving really quickly, so you can't aim yourself that way, or if the gate's not standing upright, you might actually like fall through the area up here and stuff and not even hit the goal that you need to hit. So I think it'd be simpler to just have a big circle that if you go through the circle like this, like a big hoop, if you go through the hoop, then you know you beat that that course or the level, I guess. That seems right to me. So I'm thinking like if we do little like bowl thing here, we have to like jump into the bowl, just to make sure my idea is clear. It'd be something like this. I don't know how to use this thing. This is a side view. So you basically, you know, you start over here and you just roll forward, and then you'd, you know, go through the bowl, and that would demonstrate that, you know, you're under physics control. You know, you have gravity applied to you, and that you have momentum when you roll forward and stuff like that. And then down here would be the goal, so that it would funnel you into the goal. You know, but for that moment, you realize that, you know, you have control, and it allows the player to also have a little bit of fun with the controls at first. You know, nothing complex, just to show you this is what the game is. You know, so that'd be like a level 1, basically. That's my idea. All right, let me bring all this stuff over, just so we can do a little bit of research. So this is their blueprint. You can see with that icon over there, it's a pawn, not necessarily a character. They have it out here. They have a bunch of stuff in their world outliner, which I can't wait to end up getting lost in on my own levels. I don't know, let's play this. Oh, I was doing something else. That's right. I was trying to do some blueprint tutorials on this one. So that's not the default one. Their default is that physics blueprint. So let's throw that in there. Let's delete this one. Delete this one. Put that in there. So this is what it looks like, but that's not what it looks like. We gotta do a setting real quick. We have to enable auto possess player to a first player, player 0. All right, so this is what it is. Mine is a little bit different from the original template, because they use actually torque on the ball, so they apply a rotation force. And that was causing some really weird physics to happen. Basically, your ball lost friction, and it would just like spin in place when you try to turn around really quickly. But I did a linear force instead, so that it more pushes your ball rather than rolls it. But that allows you to have in-air control as well, which a torque would not allow you to have. So it's a bit more platforming. We'll have to figure out the control details for something like this to make sure that there's not too much control. An idea I wanted to do was to do a combination of rotational torque and linear force applied, so that I guess when you're in air, you can see your ball turn. Because if I do it right now, you don't see the ball spin when I push left or right. It just stays at the same rotation, which doesn't look that fun. Hold on, something is telling me something's wrong here. It is fine. Okay, we're good. So that's like the idea I want to do behind my ball rolling mechanics. I want to try to do it from scratch though, so I'm not just gonna steal this template and go with it, but I do want to look at how they've managed to get physics on this, which is, so they have a static mesh as the root, which is what I wanted to do, and they've used a pawn, not a character, a pawn. And this is just for the camera control, spring arm and camera. I think I want to do something like this, but obviously something much closer. Let's see if we can emulate kind of what I'm looking for. 600 maybe, something like this. Rotation, yeah, let's go for like -30. That feels something more original, I think, or not original, but more closely to the original Super Monkey Ball, kind of closer to the ball. Well, you see like the little character inside, and I'm playing around with the idea of putting a character in the ball too, just to really get that nostalgia factor. But obviously the camera does not rotate at all around the ball yet. So there's two ways I could do this. I mean, well, there's three. The first way is to have a fixed camera like this where you're looking one direction. Obviously can't do that. It's just not going to work out. You know, you're going to run into walls and stuff, and you're not going to see your character like that. That's just not gonna work. Another I could do is full manual control, meaning that, you know, when you move the mouse, it moves the camera just like a third-person shooter game. I could do something like that. That's kind of what I'm leaning towards to right now. The third way, which is I think the way that Super Monkey Ball does, if I remember correctly, is to have an auto focusing or auto centering camera, so that when you press a direction, let's say that I was going to press left like this, the camera would start to pan, or not pan, it would rotate left to face the direction that you're rolling towards. I think that's the way it was done back in that GameCube game. A lovely GameCube game. But I feel like giving the player the manual control over the camera is going to be better for platforming, stuff like that. Just better control overall. So that's the basics of everything, I guess, for the whole controls and cameras and mechanics and movement. I was just messing around with other stuff in here too. I think that's all I wanted to check in here though. Let me double check something else as well. I think they have a game mode in here. A rolling game mode. I'd be interested to see what they put into that game mode. If there's anything important in there. Let's check it out. Just gonna stop this. Okay. It keeps doing this. So we have no nodes in here. Tick enable. Is there anything? It's dragon. They have a dragon for their game mode. Never noticed that. It just looks pretty much all the same. They just have a default pawn class. All this other stuff looks like default stuff. So maybe the only thing they changed was which pawn was the default. Because otherwise, I think it's usually the spectator pawn, or no, the default pawn. But it's flying movement, and obviously not what is needed in a rolling game. So let me just save this, and we'll go back to our project, which I have named MGB for short. All right, so back to the drawing board. I was thinking, like, put a little gecko in there. He's rolling around, kind of like a little hamster would. That was my thought. I don't know. That might be too cheesy and too corny and too on the nose. I wonder if second level might be good to have a little bit of problem solving, having to do with physics. Something simple, again, since it's like the first world, you know, just like going up ramps, you know, and climbing a little tower, something like that. Let's just say it was something like this, you know, and we just have we have like a little goal on top here. Well, you know, we'll use a little circle as the goal. But you start over here, the corner or something like that. And there's basically, you know, just like scale the tower type of thing. You know, there's like a little ramp here. Another little ramp going over here. I think it's something like this. Just kind of give you another idea of how game flow will work in terms of identifying where the goal is and how to get to the goal. So a small ramp and then a little landing platform up here. So, you know, basically it's going to end up looking like if this was from the front view, this, you know, this is our front view. The goal will be up here. You know, it's going to be like sunk into the ground, so it's more of a gate type of goal. I don't know how to arrange. Bring forward. So that'll be our goal. So it should be visible from, well, in Super Monkey Ball they did a preview thing. Is there? Oh, we're already up. Okay, let me just finish this up real quick. They do a little preview around the little level first. So since they usually rotate around like the center point of the map, it'd be good to put the gate at the center so we know where to go. And since we're going to rotate around the center point, we can see the little pathway up there. You know, so our little pathway is going to basically have the landing platform up here. Then one ramp going right here. The other landing platform, which is going to be like right there. You know, and that's going to continue downwards. It's going to wrap all the way around up to here, I guess. A little bit lower. Basically, you have a ramp right here as well. And since this, you know, this will be like level 2, you know, you're just going to put the character, the player, right in front of it, in front of the first ramp, so you don't have to like find it. You're just going to go up here, you know, go around, come up here, and then there you are. That might be a decent level too. because it does show, you know, the complexity of, you know, working in 3D space. You know, it's not a 2D platform or anything. But it also, again, demonstrates how you're under the rules of physics. So you have to kind of work your way up the ramps. You know, and you see you slow down here, then you have to be careful not to go over the edge, because then you have to restart. So basic problem solving for level 2, I think. All right. So first thing I notice, this is not our level. So we can do go into the project settings, and we can actually set the default level to our test. So make sure you go to maps and modes, editor startup map. We'll go to test map. Again for the game default, I guess. You know, why not? Of course, we'll change that so we don't default to the test map in the actual game. Game mode. Game mode base is fine. I think that's it that we need. So we don't need to restore. Don't restore. Okay. So then next time we set up this or start this project, we'll start in our test map and not the starter map. So let me bring up the content browser and bring up the map. All right, so now trying to find my pencil so I can write stuff down. All right, be right back. I have to get a writing utensil. Blanco's getting caught in the chair. All right, got my handy pencil. I was trying to do some complex vector math yesterday to try to slide along the surface, and I was just having a big brain fart yesterday. Anywho, all right, lighting is now built, just because I wanted to, I guess. All right, so we had this stupid, not that, the character. We don't need the character. I don't know, is there even a delete button? We'll just press delete. So, like a first thought, we're gonna go with a pawn as our base. And we're gonna set up a static mesh as our root. That's not what I meant. So we'll just delete that. Static mesh. Didn't realize it's right there. I'm just gonna call this root ball. Sure, I don't know. Why not? Root ball. And our static mesh is going to be our sphere. Or half sphere. The debug texture, or material rather. And we have it set to movable. That's good. Simulate physics, so we can apply physics to it. I guess I forgot to check something. That's right. I forgot to check the blueprint for that, the template ball. Oh well. Maybe we won't need it. But you know what? Let's set up the camera so we actually have the spring arm camera component thing that we had in the other one. So on that root ball, spring arm, default name is fine. 600. We'll mess with the actual details later. Then we have a camera. Camera's fine. Make sure you put that on the spring arm, and it should automatically connect to it. Maybe. Maybe. Do we have to set it? Maybe. I don't think so. I think it automatically connects to the socket. And let's see if it connects. Where's the setting? Am I clicking the right thing? Pawn. There we go. Auto possess player 0. So that might work. I don't know what's going on here. The spring arm has not been set up correctly yet. All right, this is gonna bother me. We need to break up our outliner into separate folders. So I'm gonna have environment, which is gonna be basically the sky sphere can go into there, the directional light, the skylight. That's good. Next, we're gonna have geometry. Create folder. I don't know what happened there. It's just not working. So let's use this button. Is it working at all? I don't know what happened. Oh, okay. Let's make sure that's up there. And okay. Let's make sure we're not in environment anymore. There we go. So we'll put our 2 boxes in there and 3 planes. Yes. So this one is the floor. Let's just rename this one floor. Angled box. You know, generic things. I mean, I don't really need to rename these. But since I'm going to be potentially debugging a lot in this, it might be nice to know where things are based on their names. Ramp platform. All right. So we'll just let that guy be there. But our pawn, let's focus back on him now. We can rename him, right? Obviously just Gecko Ball. Right? So I thought that there are no collisions. Location 0, 0. Huh. So location 600. Oh. So let's just move the spring arm out, I guess. This way? No, this way? Have I done something wrong here? I've done this before. It just doesn't look right, you know? Something's fishy. Huh. Probe channel. Socket offset. I mean, this just doesn't seem right. You know what? Let's enable the camera leg, just so we can see it I think we can see it. Yeah, you see that? It's like it's working, kind of, like this camera lag. Let's, alright. I guess it's just like, you know what? I think it's just a camera that we need to move. We can keep the spring arm there. The camera needs to move out. There, that's what it is. So the socket for the camera is over on this end, but since when we created the camera, it wasn't attached to the spring arm originally. It was set to the origin of the ball, and then when I put the camera on the spring arm, it automatically changed it from 0 to 600 to take into consideration the socket offset. So now we can change the spring arm rotation to -30. Can move this in maybe a little bit, do you think? 400. Oh, let's try something like that. Let's just play. That looks pretty decent. What if we place our ball right up here? Let's go for a little ride. So this is something I anticipated was gonna happen. So we need to have a way to detach basically the camera or the spring arm from the rotation of the ball. This is where I might have to like bounce back and forth between that template and this, because there's something when I was doing this on my own that just would not do things correctly. Inherit pitch. I don't think we should inherit anything from this. Should be a static camera. Why did I move it away? Let's move it over here then. Okay. Move it up a little bit. Okay, so that looks pretty good. I'm a teensy tiny bit worried about how the ball kind of does a little like jitter as it rolls down. Instead of like a smooth rolling motion, it acts less of a ball and more like a rock, like a boulder. Huh. We may have to change the collision. We may have to mess around with the maybe the physics override. This stuff. I don't know how to use this stuff. Maybe in here. Let's just do physics material. MP maybe for material physics. I don't know if this is like an appropriate folder or anything like that. Gecko Ball. Okay, I don't know what a physical material class is. So let's select the default. Can I edit this? All right, hold on. Let's bring up the content browser. Materials, Gecko Ball, edit. Friction. Restitution. Zero, you think? Density is fine. Raise mass to power, I don't think so. surface type. What? Project settings, physics. Physics. And then something else. Physical surface section. Physical surface. Up to 62 custom surface types for your project. I've never done this before, so this is kind of new. Sure, Gecko Ball. Okay, it's just a list of physical surfaces. Okay. Did it save? It's in there. Okay. Oh, there it goes. I don't know what that does though. I gave it a specific surface type, but I don't know how to define the surface type. I don't know. Collision presets. Collision is fine, I think. For now. We'll probably have to change it around so we can pass through certain things. Hit events. I'm not sure if I need that. What does it look like now? The same. Oh, we can like put it all the way up. Huh. Let's look at the wireframe for this. Huh, it's completely yellow. It's completely green now. So it looks like it has a really high poly count. Visibility collision. Let's try to turn that on. Yeah, what's up with that? I think we're gonna need a higher resolution on this. Visibility, yeah, the player collision is just horrible. I don't know how to change that. I thought the physics thing was the way to do it. Let's check the pawn. No? Alright, I think it's time to Google. Okay, come on, Firefox. There we go. Hold on. Okay, Unreal player collision. Static mesh in the static mesh editor. Okay, so in Unreal Engine 4, you have access to simple and complex collision shapes. Simple collision are primitives like boxes, spheres, capsules, and convex hulls. Complex collision is a tri-mesh of the given object. That's what I want, because my tri-mesh is high def. By default, Unreal Engine 4 creates both simple and complex shapes inside physics. Then, based on what the user wants, complex query versus simple query, I think we want complex. We will use the corresponding shape. Yes. Okay, so for example, in the image below, the chair on the left has symbol collision. And when the pawn above it falls onto it, it'll slide off the large angled surface that covers the seat. However, the chair on the right is using a compo as simple. Use compo as simple. It's supposed to be use complex as simple, maybe. And when the pawn above it falls, it will land on the seat of the chair and stay there. Right. Okay. So let's go into our content browser. Look in our model for that. Edit. Okay. This looks familiar at least. Can I change the material? Yes. Let's change it to debug for the default material. I think it's loading. I think it's thinking. There's a way to automatically set up your collision using this. I've done that before. I don't know if that's what I want. Let's see if we... Okay, what's going on here? Is it really frozen? I just changed one material and it's like freaking out. You know, I can maybe understand it a little bit. If you look over here, I have 8 million vertices on here. And so over 4 million triangles on this thing. So it's pretty high definition. I may have to down res that in Blender maybe. So it's maybe not that high def. General settings, LED for collision. 0. Huh. What is that? Collision representation does not change based on camera distance to camera. That seems obvious. Simple collision, physical mesh, physical material. Complexity. Use complex collision as simple. Create only complex shapes per poly. Use complex shapes for all scene queries and collision tests. Can be used in simulation for static shapes only. Can be collided against but not move through forces. It sounds like it does not want me to use this for a moving character. Complex scene queries. Let's try it out. I think I will have to actually use this collision, this auto collision thing, so we can get like a higher, I don't know, like higher density is I guess a way to say it. Higher density collision mesh as our simple collision mesh. Because having over 4 million triangles on our collision mesh may not be good for lower end systems. It may not be good for my system because it's still frozen right now. Yeah, I think I'm gonna have to definitely down res this, our Gecko Ball, because it's sitting at 4 million. I can't believe that. I don't think I need that many. But now we've said it, I guess. So guess we'll save it. I think off stream I'll try to mess around with different resolutions, both in the actual model and on the collision generated ones. So that's our complex one. Holy cow. I can't even move slow enough. Wait, that's still too much. Yeah, look how small each little polygon is on that sphere. But it's it'll probably be accurate. I'm afraid. If I press play, will this crash like everything? Okay, you know what? I'm gonna remove this one. First, let's check a look at the player collision now. Yeah, now the player collision is at full bore. Oh my god. Yeah, this is not gonna go well. Yeah, let's not do this. I might crash my computer now. Wait, I don't think it moved it at all. Yeah, it's not going to move it. Saying errors reported. Trying to simulate physics on complex. Yep, it does not want me to do that. At least I can't crash my computer. Alright, so by static they mean actually static, as in not moving. So we'll go with project default and wait 10 minutes for this to finish. Now, how do I set the collision? I forgot. I think you just, or maybe it's in this menu up here. Yeah, I'm gonna have to down-res this a lot. Not just for the sake of playing on like lower end machines, but the sake of playing the game in the editor and stuff like that. So I can actually, you know, do development and not get stuck every 5 minutes when I have to like edit a shape or something like that. And it tries to renders 8 million vertices. So let's show the simple collision. That's not what we want. Primitives, convex elements. We don't need double-sided, so let's, yes, in here. We could do an auto-convex. Let's do a, well, I mean sphere, right? Nah, I don't know what it's doing. I haven't used the autosphere yet. So I don't know if it's trying to, well, I'm sure it's calculating the right vertices and stuff like that, but I hope it doesn't just come up with what it already has. This weird, like, hexagon shape. Shape doesn't even make sense. It's got like squares on the faces, and then it's got, yeah, these are hexagons on the corners. Okay, so now we have something. What the heck? I don't know what those green lines are. Oh no. Wait. Okay, can I remove this collision then? I don't know what I'm doing. I'll be honest. But that's the fun of it all. I think it's fun. Yeah, I need to definitely down-res this off stream because this takes forever. But I hope to at least put most of the development work on stream, because I think it'll be fun. It could be a little group effort. Okay, so now we just have a shape of sorts, I don't know how high def it is. So if I go inside, you see it just... Huh. I don't know what that means. Let's just try that out. Let's see how the game handles that. Excuse me. Let's move that back over our little platform. Play. Now that behaves like a ball. With very lossless momentum, which we'll be able to change. Man, this really went kind of nuts, didn't it? I don't know why, but that's just gonna bug me if I just let the sides. What's going on? Let me select the side of that. I don't know how to select like all surfaces of this geometry. Is this oak too? Yeah, it's oak. Alright. A neat little trick if you're trying to move around quickly in the editor is to, while you're holding down the right mouse button and moving with the WASD, use your scroll wheel to increase your sensitivity or decrease it. So I just like scroll down there and I'm still moving just slowly, and I can scroll back up to increase sensitivity, which is separate from the sensitivity up here. So it's convenient for some quick moving. That's oak now. I think that's all sides. Okay. There we go. Just a little anal about everything being as it should. So that's cool. That's cool. So now if I were to add another one, just not a player, but just that, it ought to look pretty cool when we roll it down this little hill. Maybe like that. Is that? Yeah, that's fine. Let's just hide a gecko ball. Oh, it came back. That's only in the editor, I guess. I think that's all I want to do with this. Let's try to make it into a blueprint. New folder, blueprints. To blueprints, we're gonna call it not Gecko Ball blueprint. We're gonna go with BP _ Gecko Ball. I want to stick with that nomenclature, that naming style, naming convention. It actually opened up on my main menu. So that's that. So now we can just delete this. We have that blueprint ready. Now we can see this from the outside. I need to apply physics first. Physics. Yeah, it looks pretty good. See that again. Yeah, I'm happy with that. But I probably will still reduce the polygons on that so it's not so high def. Again, like, it's just a ball. We don't need the highest resolution possible for that. That'll save some frames. Speaking of frames, let me put up a console command. Unigraph. That's what it's called. Yep. So we have a pretty low frame rate. 30 milliseconds. What is that? I don't know. That's like that's like 30 frames per second, I think. I'm looking at this number up here. So it's tolerable, I guess, but I bet we could do better. Or that just might be because I'm streaming right now, so my CPU is a little bit bogged down. My GPU is bogged down, maybe. But yeah, it probably doesn't need to be that low of a frame rate for just a ball and like a test level. Imagine when we get like a bigger level with a bunch of other static meshes that have pretty good, you know, I guess quality and details of them too. So we don't need 8 million vertices on this one. Okay, let me just take that off for now. I don't know how to remove this right now, so we'll just leave it. We'll leave it there for now. But it's kind of nice to see in the corner how bad we have damaged the rendering system, all that stuff. All right. So now to start with, I guess, programming this ball or the ball. All right, the ball. So I'll change the ball model later. We don't need that to do our movement. So I'm gonna remove the defaults and let's set up the movement first. So to do that, we need to go into the project settings. Since the input mappings are per project, we need to specify them in the engine section for input. And we're going to have the axis mappings, 2 of them. Move forward and move right. And this will be relative to the camera, hopefully, once we get that done. Let's go with just normal WASD controls for now. You know what? I'll also add on a gamepad too, because I have my Xbox controller already set up. W and S for forward and backwards. Not gamepad. Here we go. So the scale, W is forward, so we need that to be a positive scale, but since S is backwards, we just need to put this to -1. You know, the opposite of it. Do the same for move right. So we have D for moving right. That is positive. And keyboard, we have A for left, which will be -1.0. Now we also have the gamepad stuff. Left thumbstick. There's a couple ways to do this. You can either use the X and Y axes, I guess, axes. Terminology, I don't know. I was never good at English. So let's do it 2 ways. Let's do left thumbstick up. No, let's just stick with the axes. They worked before. Y-axis for moving forward, and the X is for left and right. Left thumbstick, X-axis. So that should be good. Now I want to test that out first. That's the first thing I want to do. So we have our move forward and move right. These axis values, since we now declare them in the project settings, they now pop up in the blueprints. I'm just gonna stick with blueprints for now. I was thinking about, you know, C++ doing code. I will do some of that later, I'm sure. For now, I want to see if we can just do this in blueprints, just because it's more visual and prettier looking. So move forward. That's not what I wanted. I want the event, not the data. That's how you get the value of moving forward. But there's an event for moving forward. The axis events. So that when any move forward input is pressed or sent, it'll fire off an event, which means that we can call functions and whatever in here immediately. So just to test things out, I am just gonna print the value to the screen. Print text, print string, I guess. And we'll do string from to string float. So this will convert our float value right here into the string. And we'll run that. Let's move this down. So it'll just print out the axis value for moving forward. So let's do the same for moving right. Now, if you remember, if you remember correctly, I set the axis scale from -1 to 1. So let's see if we get that -1 to 1 when we use all of our different inputs. So move right. Event, not the getter. And I'll just copy this. Line that up so it looks nice. That lines up. We'll save this and compile it. So very basic. We just need to put the actual blueprint in our level. So let's do that. Okay, I'm gonna remove that other ball because it's actually messing up with my frames. With that enhanced sphere collision. Yeah, let's just stick with this for now. So now we can test out WASD in our actual game when we play it, and we should be able to see it pop up. Actually, before I do this, I want to change the color. The light blue is a little bit too bright. Let's just have like a red, kind of like a debug color. Sure, we'll just copy this. The same over here. Actually, let's do a different color. Something like this, maybe. Like a purpley color. Move right is purple, move forward is red. So another thing that you can do is if you right click a node, there's a couple settings where you can like break the link so you don't have to connect it anymore. You can select all output nodes, so it'll select whatever is connected to. But a thing that I like is strain connection to print strain, or to whatever is connected to. So if you click that, it'll just make this connection straight, which improves the quality of the visuals, since this is supposed to represent like a flow chart. Having, you know, smooth lines and smooth, I guess, flow in your graph makes it look better. And since it looks better, it's easier to work with. So that's compiled. I'm just gonna skip saving it. So now that we have that, we can test all of our things. It's doing this thing where, you know what? I'm actually just gonna put in a branch since it doesn't seem to like. It's calling this like every tick or something crazy. I don't know why. Is there like something can change with this? Consume input, execute when pause, override. No. so let's do a branch so that if what I'm gonna do is if the input is not 0, then we print it. Otherwise, if we're not pressing anything, then it will not print to the screen. In order to do that, we need to set up a condition. So we'll do not equal. It's for the float value. So now it's already starting to get complicated. So this is where having good flow control, visual flow control, will be very helpful. So we'll just do that. And we'll also set that right there. So if it's not equal to 0, then that looks good. If it's not equal to 0, then you go into the print string. Otherwise, do nothing. All right, that seems good. So line that up right there, kind of like that. And then that goes to there instead. That'll break that link. Let's move these down so they're not running into the move forward. We'll kind of replicate what we had the orientation over here, or I guess above. It's down below like that-ish. That seems about close enough. And we had that going there. All right, that looked good. Looks pretty good. Yeah. I don't know why it looks different. Anyways, this is moved up a little bit. Okay. I guess that, oh, that's whatever. Yeah. I was getting a little anal there. It's good. Oh, okay, Xverse is still playing. So now it's not printing anything until I press like W. Then we're seeing that pop out. So since it's keyboard, it's either on or off. So we get 0s or 1s. So same for S, but it's a -1. So that's all working correctly. A is left, so that should be -1. And then D is right. So that should be +1. That's good. Now for our gamepad, let's see if this works. This works. Okay, so now if I press up, we get 1. And now I'm pressing kind of diagonal. And I'm going all the way to the right now. So now we're full right. Let's go full left. Now we see -1. Full down is -1. Then move forward. So that's all working correctly. Same for the keyboard. That's all good. All right, so that's the basics of inputs and mapping, which is much more simpler in blueprint form than coding form. Excuse me. All right. So we will just we're just gonna break this apart. Let's do the same for this actually first. Okay. I'm just gonna kind of move it behind it into a comment, I think. Debug input values. Debug print input values. Okay. So now that's just kind of behind there. We can access that if we need to, but we're moving forward. Get it moving forward. We're not moving forward yet. I need to actually do some stuff. So basic way I want to move forward is to apply a linear force. So let's see if that's in here. Add force at location. And what do you know? There is one, and it has the component already in there, which is our root ball. Obviously, we can't apply a force to the spring arm or camera, so they're not static meshes, I guess. I assume that's what it is. This seems fine. This is location in world space. So I think this is what I want. Let me move that down. Straighten that out. Okay, so this is the basics of the movement. So we have our X value that we printed out before. So let's go from -1 to 1. Now to make sure that it actually is -1 to 1, I'm gonna clamp it. So let me just show you where that is actually. This would be a better way to show it. So in the math section, I believe we can just go to float, and there's a clamp. So it says in this tooltip, returns value clamped between A and B inclusive. So that means it's just basically round down to the values we specify. We want it to be from -1 to 1, and we want to clamp this value. Now the return value is going to be clamped between there. So if we just happen to have a value that's greater than 1 or less than -1, let's say, a way that this actually happens is if you have multiple inputs coming in, which we could have with our gamepad. So if you press up on the gamepad and you press W, that's basically 2 inputs coming together. So it's gonna actually add them together, I think. So it's gonna end up being 2.0 instead of just 1. And since we don't want to move faster, if we're pressing W and controller up, we want to clamp it down so it's the max is the maximum we can go. So let's give ourselves some space now. So now that we've clamped that value, this is going to basically represent a percentage of our velocity, or I guess the force that we want to apply. So since this is the force, we want to apply our forward in the direction of our camera. So this is where it's going to get kind of tricky. So actually, instead of doing that, first off, let me just do some basic force. If you go into here, we select our ball. This is our camera, our little preview camera here. The forward direction is going off into the distance over here. And that's denoted by the red arrow line, which is the x-axis. So you can see down here. So that's the positive x direction. That's forward. And then positive y direction would be to the right of our camera. So let's say we just had a static camera, like I was showing you in the rolling template before. So forward again is the x direction, right is the y direction. So let's just assume we want to place that into here, or I guess x for forward. First we need to make a vector together, because the force takes a vector of x, y, and z to determine in which direction to push the force, right? Yes. So we need to make the vector, which has 3 values. We only have 1 value. How do we do that? So we go into here and we search for make vector. It's that simple. And we want to use the normal vector, which is composed of x, y, and z. And we will put that in there. And like I said, forward is the x, so y and z will not do anything. If we wanted to, I think we could just combine forward and move right. Maybe we could do that. But then I think, well, this, yeah, we could do it. You know what? Sure, let's do it this way. I'm gonna copy paste this. So we have -1 to 1 again. and that's in the Y direction. Let's see if that works. Let's compile that, and let's see. So I press right. Let's go right. Nothing's happening. Let's go forward. Nothing's happening. So what's going on? What if I pause this real quick and we go over to the gecko? Okay, so I was pressing forward and right, I think. Let's check. No, I wasn't, I guess. Let's see if I can actually pause it. I don't know. Is there a hotkey for pausing? I don't know. Did that do it? Did that do it? Okay, so okay, let's step back here so I can explain what I've just done. So a pawn is possessed by a player, and by default we set it to automatically possess player 0, or the other way around. Player 0 possesses the pawn automatically. So that's what this button up here is, possesses. So we can attach the player to the player controller, which is going to be in the pawn. But since I depossessed, we're not in control anymore. So that's why I can actually move the camera around and I can see the actual like character. But we're still playing, mind you. We haven't paused or stopped the gameplay simulation yet. So that means when I was pressing like forward and to the right, and I pressed F8 to depossess, it actually retained those values. So we can see in here it says current value 1, so I was pressing D, and forward is 1 again for W. So we see that they were clamped. Okay, so the clamp returns 1 and 1 for both. It makes a vector into, you can see X equals 1, Y equals 1, Z equals 1. Alright, so if our force is 1 and 1, then, you know, why aren't we doing anything? You know, what's going on here? Let's check our, let me check our gecko ball. Oh, wait a second, something's happening here. And you can see here, it's actually moving. Just very, very slowly. So we're gonna have to add on a modifier to this to make it not move so slowly. And you know what? I'm just gonna apply a scalar vector, or a scalar to the vector. So let's break this link, and I'm just gonna do vector, but then the asterisk for multiplied, and then float. So let's move these over. So now we have a multiplication node here. So it's going to be the vector. That's going to be like our force vector. And now we have to add some kind of force magnifier, basically. So we could set a constant, you know, like 1,000. That might work. You know, let's just test this out. Test this out to see if 1,000 does anything. Compile, play, and am I playing? No, still nothing. So let's check the thing again. Okay, so now we're actually moving a little bit more. You can see the ball is doing this little quivering motion if you look very closely. So it looks like it's a little bit better, but we're still not moving pretty much at all. So let's go even bigger. So 100,000. Let's try to apply that kind of force. Oh, now we're, what's going on here? There's something weird going on here. I wonder what's going on here. We'll figure that all out a little bit later, I think. It may have to do something with this, so just look out for that. But we could go back and forth trying to see what a good value would be for that. But that's not a good way to do it. The best way to do it is to make a variable for this, and we're gonna name it force. I don't know, multiplier. I can't. I have some issues sometimes, and this is going to be a float. So what we can do is we want to make this force multiplier. We want to get that, of course, and we're going to set it up right around here and hook that into our multiplication. So now we're multiplying our input vectors by our force multiplier. But how do we change the force multiplier? What we have to do is we have to make it editable. So on the instance of the blueprint, you can edit each property that you make available. So this one is now available. You can tell by the little yellow eye icon here. And now a good thing to do is to add a tooltip so that when you're actually seeing it in the editor, let me show you what it looks like first. So let me compile the blueprint, head over to here. We'll click on our blueprint. We're in pause mode right now. So I'm in right here, clicking on the pawn. Expand this. I never have enough room over here on this monitor. Under default, we now have force multiplier. So now I can change it from here. So let's say if I were to go and play this, I hit F8 to depossess real quick. I go into here and I say 100,000 was doing something weird. Let's go to 1,000,000. Okay. So we go back here, press F8 again. And now we're in possession of the pawn. So let me press S again. Okay, well, now we're doing something again. Pressing a lot of buttons. Stuff's happening. So, hey, at least that value does something. For some reason, the surface material of our pawn is now something completely different. I don't know when that happened. Anyways, something happened to our camera too. I don't know. I don't know what happened to that. We're not going to talk about that. What we're here to talk about is this value. So maybe that was a little bit too high. Let's go to like 80,000. You know what? No, let's go back to 100,000 and see what that was like again. So now I just go back into here and I press F8 again. Now I'm in control again. And now I can see, yeah, something's weird going on, but at least my inputs are actually doing something. So now I can stop it. And when you go back to it, you see that the value returned back to what I set it before we press play. So remember that, yeah, your changes during play mode aren't saved. So make sure if you find a good value, like let's say, oh yeah, 100,000, that was a good value. You know, we'll put that into there. Press enter, and now it's saved onto this instance of the blueprint. So now this player will always have 100,000 for the force multiplier. So that's a good way to basically change properties of blueprints on the fly. You know, good for debugging and testing purposes. You can see my frames are just going really badly, really poorly, I guess, right here. But another thing you can do with these variables is you can apply a default value to this. So let's, you know, put, just for difference sake, 50,000 as our default. Let's compile that. I don't think this will have changed at all. It still remains at 100,000. But if I were to make a new pawn or a new blueprint version of this right over here, let's bring that up. Now you can see that 50,000 is the default value for the force multiplier. So now if you were to have some people, some like level designers that didn't really know how to do the blueprint programming, you could do something like this where you apply or you expose properties for blueprints such as characters, or I don't know, maybe like a doorway or something like that, or not a doorway, like a door, so that yeah, like a door opening speed changes, you know, depending on like a variable for that, or maybe there's like a bird blueprint that makes a different sound depending on the variable that you expose. So that's all good and dandy. So let's delete that extra one. We'll stick with the one that we were working with before. Now the thing that I think I want to do is I want to change the slider range on this to have a minimum of 0. I don't think I need a maximum, but I don't want to go into negative force. I think I'll do the same for value. So slider and value are two different things. The slider is the thing that you see on the UI. So let's say I max this out at 200,000. Let's say I didn't want my level designer to get a little bit too crazy and apply like a really huge force multiplier on our character. But what I could do is for the value range, actually set it to something higher, like 500,000. So if you really wanted to, he could go much higher than 200,000, but he has to do that very knowingly. He can't accidentally do it, basically. He or she, I guess. I don't know who I'm talking about. But now if we go into here, you can see in the little slider UI, our bar is halfway because we're at 100,000. So I could actually increment that all the way up to 200,000, and I can't go any further. I can go from 0 to 200,000, but no higher. But I can overwrite that if I say 300,000. If I just type it in like that, it'll work. If I try again to slide it, it goes automatically back to 200,000. You know, I could go up to 500,000. That's not 500,000. That's 500,000. So I can actually set that. If I try to go a little bit higher than that, let's say 600,000, it's going to resort back to the maximum of 500,000. And I try to use a slider, it goes back to 200,000. So if you're making blueprints for in teams and stuff like that, this is one way to regulate things so things don't get out of control accidentally. Or if you're doing things and, I don't know, you get drunk or something or tired and you accidentally set your character movement speed to 2 million instead of 2,000 or something like that, you know, you could prevent that from happening. But I'm actually going to delete the maximum because I don't know a good value for that yet. The rest of this, I don't really care for now. I forgot to show you the tooltip. So the tooltips are the things that show up when you hover over things, like X value, or if true, this pawn's pitch, la 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 la. When I hover over this, it just says force multiplier, the name of the variable. But that's not very descriptive. You know, we could add something like this where someone who might not know what the force multiplier is will know that, you know, this value will change the magnitude of the force applied during movement. So let's just do something like that. I don't remember this, like increase applied force for movement as a multiplied value. something like that. So now when we compile this, we can go back, hover over this, and it says increase applied force. That doesn't sound right. I worded that horribly. But yeah, it pops up there. So I'm just gonna rewrite this. Magnitude of the force applied during movement. All right. So that's the basics of variables. I won't go into too much depth from here on out. But now we need to do something about that weird wackiness going on. Something weird was going on. So this says add a force to a single rigid body at a particular location in world space. But I'm not sure if that's right, because in world space, that's not necessarily where our character is. If we look at our character, we're at, 1200x, negative 800y. That's not at 0, 0, 0. So, like, there's a couple ways to do this. We could look and see, well, we have add force at location. What other kind of forces can we apply? Add radial force, add force at location local, add force. Maybe we could try add force. Huh. Let's try this one out. Delete. And we'll delete. Yeah, we'll just delete it. It's easy to remember if we ended up wanting it later on. So now we're just gonna place our movement, our multiplied input of vector into our force vector. Put this down here. Let's move these over so it's a little bit more compact. And we're gonna hook up our input execution so that once we get an input, we'll execute the add force function, or I guess node. Bone name, it says for skeletal mesh components. We don't have a skeletal mesh, so no worries there. That's probably for ragdoll stuff, modifiers, forces, stuff like that. Acceleration change. If true, force is taken as a change in acceleration instead of a physical force. Mass will have no effect. Yeah, so force will take an account of your mass, because from physics class, force equals mass times acceleration. So if we apply a force, its acceleration is going to be dependent on its mass. Unless we just say it's an acceleration change. Then we just say this character is going to move with this type of acceleration. And we want acceleration, and we don't want a static velocity because we're making a physics-based game. That's why we're not doing some kind of movement, like a teleporting movement or whatever. That's basically it for that. Let's see how that works. I can't really line that up. Just gonna compile that, and let's play this. Hey, that works pretty good. Except it's kind of slow to change directions, but we can move in the air and stuff like that. We can move in a diagonal. I'm using the gamepad now. Alright. I can move slowly. It starts to pick up speed. I'm still haven't moved very much my thumbstick. I'm gonna go all the way to the left of my thumbstick and let's see how fast it goes. It's going pretty quickly. I'm gonna have to disable the camera lag too, I think. There we go. If you press F on a thing, on an item, it'll automatically focus to that item. Just a little shortcut. So let's go back into there. Spring arm. let's see what we can do with this camera leg. Camera leg might not be bad per se. Let's just see what it looks like without it. Kind of doesn't really give the camera any character, does it? I mean, it stays with it at least, so when we're moving quickly, you can see, oh no, okay. But let's see what else we can do with it. We could do camera rotation leg. Nah, we don't need that. Camera legs, but what if we just, let's read that again. Controls how quickly camera reaches the target position. Lower values are slower, higher values are faster, while 0 is instant, no lag. So let's put 100 on there. That might be too high. We can also set the max distance. I wonder. That's pretty much no lag. That seems a bit too high. It's pretty much as if we didn't have any lag on that at all. Let's go into like 20. Let's double the original. Okay, there is some. You can see like the camera starts to fall behind a little bit. Let's see. I want to test out something. Let's have a really low lag speed so it's very apparent. But I want to see how much the lag actually goes. So that's pretty much off screen. All right. It's a bit too much character, if I were to say, if I were to put it that way. Let's see what 10 does on the max distance. That's pretty close. We could probably increase that a little bit more. Basically, I want to prevent the camera when our ball is moving really quickly to escape the view. To prevent it from escaping the view of the player. Let's try that again. That's not bad. Let's just put it like 25, just so we know that it'll never get too far away. And now let's put this back to like, let's try like 15 maybe. That seems pretty good for normal movement speeds. But we're not moving really quickly. You know, we'll take some time to actually get going. So I'm going to mess around with two things. So while I've added a linear force, I might want to do a rotational force. Add a radial force. I remember, was it torque? Torque in degrees. That might be more what I'm looking for, I think. I don't know how the math is going to work on this one. Let's just see what it looks like. Oh, we can't have multiple ones. That's right. So after we apply our force, then we're going to add our rotation. Let's see what happens. Is this a vector? Yeah, it's a vector. Direction of axis of rotation, magnitude is strength of torque. Let's just take our input vector, our multiplied input vector, and see what it looks like from there. That's not going to look pretty. Let me just keep it right there. Um, now, in order to test this, I'm going to need to remove friction from the element. Because if I use my linear force, you know, we saw the character, the player rotating. So, I'm just going to go over here. So now we're just above nothing. Yeah, let's that'll work. So our rotation is now doing nothing. Why is it doing nothing? Let's do a quick debugging. Let me just save everything first. I mean, I trust autosave, but I also don't trust autosave, if you know what I mean. So I'm going to press just D, and I'm going to unpossess or dispossess, I don't know a good terminology for that. Dispossess the pawn, and let's see if we are rotating to the right at all in the game, I guess. We can check the transform details. You know, we can see if any of these values change, and we can go into the blueprint to see what's going on there. And now press F8. So now our ball is going off to the right. So we are rotating the pitch, which I don't know if that's the right one. But it is being called. It's at 200,000 in the Y direction. But that's our pitch, which is up and down. I think X is going to be yaw, and Z is going to be roll, I think. Is that right? That's pitch value. This is roll. This is yaw. Okay, so it's X and Y. But Y is going to be when we're moving forward. Okay, we despawned. So that was good though. That was good. So Y is pitch, which is basically when we're facing forward, pitch is going to be rolling forward or rolling backwards. So let's we're going to have to switch that. So let's break this link real quick. I'm going to do something else to this vector. I think the simplest way is just to reassign it. We're going to break the vector, and then we're just going to make a new vector. Not make noise. That's no. Make vector. But we're going to say X is going to Y, Y is going to Z, or Y is going to X, X to Y, Y to X, Z to Z. Because Z should be 0 anyways. Right there. So that's our Y, or Z was yaw, which we don't need to change yaw at all. So that should give us a better representation of rolling in the direction that we press on the keyboard or on the gamepad. So let's look at it now. Then we press F8, and now pressing D, going to the right, X is now decreasing. I don't know if that's good or bad. We may need to flip it and say, can I close this window? I don't think I need that. What was I saying? Positive or negative, I don't know which is good. But we're not moving enough. So another multiplier is in, it's going to need to be in effect. Yeah, we can just, this seems right. I was thinking of the flow of it all. I don't think I'm going to parameterize this one. What we did over here where we made force multiplier available, I think we're gonna have basically a static variable in here. A variable that can change, that cannot change. To make that clear, because if you're gonna expose this to the editor, then like we do some really crazy rotations or anything like that, it would be up to the editor, which doesn't make any sense. We want the rotation to be I guess connected to the force, so we're just gonna have the one scalar operation here, and this scalar is not going to change as a variable, but we will have a static scalar. I'm trying to say this, it's so weird, but I think it makes sense. Let's stick with 100. I'm thinking, can we just, for the sake of debugging, we'll expose that. We'll rename it. We'll just say debug. Torque mult. Torque mult. Compile this. Default 100. That sounds good. Editable. Tooltip doesn't matter. It's debug text. So now we have our debug multiplier here. So now we'll be able to modify it in game. We're rotating the wrong way. I'm pressing D and we're rotating to the left. Wrong way. Let's just stop that right there. What we can do is we can add a pin to this, I think. Add pin. No, we cannot. All right. Torque, the torque multiplier. Torque with an E. Compile. Let's just that's all we need to do. Put a negative on there, so that'll flip the rotation. I hope that's right for the y-axis. I only tested the x-axis. And I think we should probably increase it a lot more. 500. That should be our default. Now let's check right. We're now rolling to the right. Left, now rolling to the left. Let's equalize. Forward. It's now the wrong way. Okay. Let me just make sure it's the wrong way. Rolling forward, and we're rotating backwards. Okay. Good to know. So we're gonna need to do that in here. So let's just make this positive. But that seems okay. Just put that up there. I'm gonna use that straighten tool to do that. I'm just gonna move these over here. Need to break the link on Y. No, on X, because it's coming from Y. And then we're gonna copy. No, it's a different multiply. So we do float times by float. This one. Plop that in there. It's gonna be this. Let's put it up here. -1. So we're just gonna flip the value on that, and that goes into the X for roll. So that seems good. I think I need to increase the value on the rolling though, because it kind of goes a little slow. I think maybe we can increase that some more. Okay, rolling forward. Good. Rolling backwards is now slowing down, and there we go. Now, a thing I want to do is I want to ignore mass. I think I want to ignore mass. So I'm going to put check acceleration change to always be true. So now we ignore the mass of the sphere. I don't know if that'll ruin things. Let's go into here. Let's check the rotation again. See that? That's too much. That is too much. So I'm gonna stop right here, and I think we already despawned. I think we already despawned. So let's go down to 1,000. And rotation, let's do like 10. Maybe those values will be okay. Let's actually change this to 100. I'm afraid of just launching myself again. So that seems good, right? That's still pretty quick. F8. Gecko Ball. Torque, let's do 1. Let's just check 1. Possess to the right. That's too slow now. F8. Gecko Ball. 3. Possess. That seems pretty good. I wonder if there's a way to, okay, so that's pretty good rotation, that 3. So let's go into here and change the default to 3. I wonder if there's a way to basically prevent, well, to add a maximum rotational velocity. Because you can rotate really quickly in here. And I might want to limit that so you can actually see your character. If you hold shift while moving components and stuff like that, your editor camera will follow you along like that. Alright. Let's see if this is good enough. Let's move it down. Right there. That's good. Let's check the force. The force is pretty good right now. We can move pretty quickly. Changing in air is still kind of hard. So I want to be able to move. I want to accelerate quicker, right? So I want to increase my force. But if I increase my force, then we're going to go a lot faster, obviously. I think, what I'm thinking is either we're going to have a force input curve. I don't know, can I draw like this? Yeah. I'm thinking maybe a force input, like we have a really high force at first, and then we kind of steady out, right? So that's basically like a velocity curve, right? So that means our force would look something kind of like this, maybe like this. Yeah, something like this, where we start off with a really high force, but as we approach a higher velocity, we start to scale down a bit, and then we reach a constant force down here. So this force is like this constant force. It would be just enough to combat the like the other forces due to like friction. Would it be friction? I don't know. And also well, air friction, technically, quote unquote air friction. Because basically, I think in here you can change the physics of things. Maybe. Linear damping, that's what it is. I don't need this, I don't think. So linear damping and angular damping. So as you can see from the tool tip, drag force, which is like the air friction basically, you know, quote unquote air friction. It's different types of forces together, kind of. I don't know all the physics to it, but I know some. So we can add drag force to reduce the linear movement. So basically, if we increase this, if we play this right now, we move pretty quickly. If I try to like turn, it takes a while for me to slow down and go back the other way. Let me also try to, I cannot stop. I'm gonna press right for a little bit and then let go. Right, so I'll tell you when to let go and we'll see how far I move. So go, let go. So we moved all the way across our flat little floor here and rolled right off. So we don't want that. That's a little bit too much momentum right now. So let me go into my physics in here. Now let me increase this to 0.5. This might be a bit too high, but if I press D and now I let go. No, what are you doing? Oh, okay, I just lost connection there. I think we're good now. My recording software just kind of stopped. I don't know why it did that. Anyways, that's linear damping. We can also apply the angular, I think it's called damping, which will basically help reduce the torque that we have. So reduce angular movement. So like the rotation around the rolling axis, the pitch axis, stuff like that. So, you know, let's add 0.1 maybe. And let's move our character off the side. Now let's do the same thing. I press D for a little bit and then I let go. I'm gonna start slowing down our rotation. Starting to slow down now. Starting to slow down. I think we could probably increase that even a little bit more. Now, a thing I forgot to mention, which is pretty important. I'm changing things for the instance of the blueprint, which means our actual blueprint, which is in the editor, actually isn't changing with this. So I'm gonna have to actually like copy over the values for this onto the blueprint. Let's say 0.3. Let's see what that looks like. So I'm pressing left, let go. That looks pretty good. It slows down pretty quickly. So we're not just spinning infinitely. It's a bit more realistic. It'll help to, I guess when you're moving quickly, identify, if I do end up having a character inside, we can identify the character easily. We don't make our character sick. And we have the linear damping as well, which in combination with the angular damping will work to stop the fall quicker. So keep that in mind. So that seems pretty good for good rolling. Well, I might lower the linear damping later on. For testing purposes right now, I'm just gonna leave it where it is. You know, once we have like an actual level where we're testing things out, we can see if that's way too high, which probably is. I'm probably gonna actually lower it right now to like 0.4 or something like that, because it's a rolling game, so we want to be able to roll. We don't want to make our character go, or our players move too slowly. So we'll just stick with 0.3. So like I said, I've been modifying the instance of the blueprint, which means if you see, like, there's the reset the default buttons here. So that means I've only changed things in the editor and not in the blueprint editor. So you see in the top left, I have components here, and these are the same components that we have in the game. Now, I think here is these values. So as you can see, they're not what I've set in here. So I'm basically gonna have to match. Let me just match like this. What I've done in the editor in my blueprint. So root ball, physics, linear damping is 0.3. So is our angular damping, 0.3. I don't think I've done anything else with this. Lighting. Everything else I think is fine on the ball. Let's go to the spring arm. I think I changed some values on this. Target arm length is the same. That's all good. Camera leg. The camera leg has not changed here. So change this to 15. Camera leg max distance is at 25. So that's now set. So you can all see like that a little reset the default thing disappeared here, because that is now equal to the default of the blueprint. Now you can see the blueprint has one because this is changed from the default of a spring arm component, the main spring arm component. So now, like if I were to place a new spring arm in this component, it would have like a default value of 0 here and 10, I think, for that. But I think this all matches up now. I'm not sure what, like, what was it? This one? I don't know what the default material would be, because I'm pretty sure the default material is debug ball. So these should be the same. But I don't know why it's like that. For the camera, I don't think we've changed anything in there. That looks out clean. So I think that's it for that. That's a pretty good character. Let's just see how it feels again. All right, I was thinking about the movement curve. And now it's time to make something interesting, I think, for the movement curve thing I'm thinking about. I'm going to make a large ramp right off the end here. I want the window modes. I might just do geometry. Can I extrude? Local coordinate system, close. So let's make a couple segments. Let's make 6 segments, I guess. I don't know if that did what I wanted it to do. I don't know exactly how to use this. So now I want to go back to edit, I guess. I don't know what that 6 segment thing did. I don't think it actually broke it up into 6 segments at all. No, that's not what I want. Let's extrude this. Don't show this again. I don't need that. Let's go back to 1. And I think I should just do this maybe. What happens when I delete this? That's not what I want. Okay, wait. I don't quite understand what I'm doing here. This is a in progress skill I'm doing right here. Let's just delete this. And delete this. And delete this. And delete this. Let's just start over, basically. Now what happened here? Let's just Control Z that. I'm going to Control Z all of it. Until that mistake is no longer there. Almost there. Oh, there we go. You know, new geometry. new box right around here. Move that off right around there. Move that down. That lines up. Let's try to select that line. I'm starting to use like Blender controls now, and this is really starting to hurt me. Click the line, there we go. So now we can line this up with our edge here. Let me scroll down a bit so we can get finer controls in our movement. There we go. So now that's lined up with that edge. Let me click on this edge. Bring that down. Something like that. Just for now. So now we're just going to move this down a lot. Something like that, maybe. A lot further. A lot further. Kind of getting used to the controls again. Maybe like that. Let's scale it up. Want to scale this side too. The side. There we go. Scale it like that. So now that should fit the ball just fine. But we need to go down further still. Like that. I don't know how to change. I wish I could like do like this direction, but I don't think I can. Whatever. I'm trying to think of a way to do it, but we're just gonna do it this way. Now I'm thinking about how we can kind of monitor this little experiment. Because going off into the abyss like this, it's not really much to show off. So, now that we have that mess, what we want to do is what can we do? I have an idea. We're going to call our tick event right here. So that's now a new event under here. And we're going to do a little debug thing. So print strain. So basically every tick we're going to print out a strain. You know what that strain is going to be? Get velocity. And then we want to get length of that. Wait, what is this? This is a vector, right? Pretty sure we can get the length of that vector. I don't know why that wasn't showing up before. Vector length. So the vector length is basically just the magnitude of the vector. And now we want to put that into a string format. So we go to string. So now that'll turn our float value into a string. So that'll give us our absolute velocity. Convert it to a string. And it'll print the string out every tick. And let's just do that. So it only pops up for the duration of the tick, I guess, basically. Let's have a pretty dark green color, I guess. Make it more greenish, I guess. Sure. Maybe something like that. That looks okay. So let's see if that'll work. So here we are. Now you can see in the upper left, we have our current velocity. This is in centimeters, I think, per second. Centimeters? I don't know. Now this looks about right. No, it doesn't. Yes, it does, I think. So we stay still, it'll kind of go towards 0. Kind of like that. Yeah, okay, that seems about right. So let's, oh boy, where'd I put that RAM? There it is. What if I just roll off? Let's see what it looks like. So I'm not pressing any inputs now. We're steadily increasing. Maybe not as fast as I want it to go. So I might change that linear damping. And we jumped off. So we got to like what? It was like 1200. So what does that mean? What does that get us? So our linear damping, it could probably go down a bit. Let's change our linear damping on that ball. Let's go halfway, 0.15. Same for, let's go with angular damping of 2, because that might be slowing down our rolling down the hill descent. Also, I'm going to put a little indicator to know where this is. Got a little cube here and a little cube over here. So now we just kind of put that up there. Put that up there. And you know what? I want to paint these. Can I change which color? Paint color. I want to paint this red. Pure red. How does I don't know how this works. Fill selected mesh with the paint color. I don't know what this is doing. Am I doing it? Vertex colors. I don't know what that means. I just want to paint it. I know if we go into RGB, like it paints it, which that seems right. I got like bucket on there and yeah, it seems okay. But then I turn the color view off and it turns off. I don't know. I don't know how to paint yet. At least we have little indicators. But now if I'm rolling forward and we're moving really quickly now. Holy crap. And now we're going faster with gravity applied. But I let go now. I might want to cap that velocity because that's freaking fast. Let's try to roll without pressing forward. Let's see how fast I go. So that seems like a better linear damping. Not moving too quickly. We almost reached 2,000 before the end. But I think, if possible, I'm going to try to do a little clamp on our velocity. Which we can do every tick. So let's say after we print our strain, can we set velocity? Set velocity. There's only like physics velocity. I wonder if that's okay. Let's put a reference to a root ball. Let's see if there's a different one. Get component velocity. No, all physics. So let's just go with that. Set physics linear velocity. Let me organize this a little bit. Move these down. That looks decent. All right, so our velocity. All right. How can we do this? Because it's doing it in the X, Y, and Z. Add to current. No, we just want to clamp our velocity. So I could, just very basically get the. Well, we have the velocity already. I could do something very simple, like break the vector out. And then we could just do a float clamp. Okay, clamp vector. No, that's vector size. We didn't do that. We can clamp this. Just do -2000, because that's like basically what we reach at the end of the platform. So we can say don't go faster than 2000. Of course, we can expose this as variables in here too. I don't want to do that right now because I just want to see how this works right now. Let's move that out. Make vector. So we're going to make a vector again. Always need more room on here. I would think there's a better way to do this, but maybe not. So we're going to clamp our Y and Z's to the same value, -2000 and 2000. And then we're just going to remake them over here. So that's a very simple clamping. Just each component of the vector is clamped to 2000 and then place in our new velocity so that we never go faster than that. You know what? Let's see if that just works straight out. So we can still move around. We're not going to be limited too much. Actually, 2000 might be a little bit too low because now we're clamped already. Let's just let's go down the ramp. I'm gonna press forward again so we can get faster. You can see we're clamped already. Our X is probably moving already at 2000, and our Z was moving pretty quickly too. So it does work, but let me show you something with clamping each individual one individually. Is that if you press like both directions at the same time, let's say X and Y at the same time, it goes well over 2000. It goes over to over 2800. That's because the magnitude of the vector exceeds that velocity, which makes our maximum velocity kind of kind of like a square instead of like a circle, if you could think of it that way. So I'm thinking, what do I want to think? You know what I'm gonna do? I'm gonna do this. I'm going to search for vector length. Well, we already have the vector length actually. It's right here. So this will be the magnitude of the vector. We want this to be a maximum of 2,000. So instead of limiting each axis to 2,000, we're gonna limit the absolute velocity to 2,000. So let's do a branch right here. So let's branch after the print string. This is gonna look ugly for a little bit until I get this debug text out of here. So after we print our string, we're gonna see if we are over 2,000. All right, so we're gonna take our vector length value and we're gonna do the greater than. So for greater than 2,000, so in this case, let's move all this junk over. That looks decent. Okay, good. Let's move this guy up here. So now the result of that greater than check, we'll see if we're greater than 2,000, then set the limit velocity. Otherwise, we don't need to set the velocity. Move these down, move this down. We're actually not going to break out our vector anymore. What we're actually going to do, excuse me, so we check if we're greater than 2,000 for our absolute velocity. If we are, then we're going to set the velocity. We're going to set it to what I want to do is I want to get the unit vector, the normalized vector. So this is where vector math comes into games. So normalize. This returns a unit normal version of the vector that is input A. So our input vector is going to be our velocity of the X, Y, and Z components. And what a normalize will do is it will change every component so that the length is equal to 1. So let's say our velocity was like X equals to 2,000, Y is 0, Z is 0. Then our vector length will be 2,000, but since the normalize function will normalize the vector length to 1, it will have to change X to 1 as well, so that it's has a X is equal to 1, Y is equal to 0, Z is equal to 0. It's pretty simple. But when you have, let's say, a combined vector of like X and Y, let's say we have X is 1,000, Y is 1,000, then our vector length is going to be not 1,000 because we're moving in both directions. They're going to basically sum up, and you have to do some vector math. You want to get into vector math, kids? How do I add a new page? Right there. All right. So let's say we have an X component on our vector and a Y component. Just ignore that this is not like normal math where Y is the vertical and X is the horizontal. Unity is weird. Or not Unity, Unreal. If you... Where did our Gecko Ball go? Focus on the ball. Are we going to focus on the ball? I think it's thinking. Let's give it its time. Basically, if you look at while we have this snapshot of Unreal, X is in that direction, the up direction, I guess. Y is to the right. If you're trying to make Y the vertical, X will go off to the left, which is not like normal math coordinates. I don't know why it's like that. I'm sure there's a reason for that. Probably the history of computer graphics and stuff like that. I should probably know because I took computer graphics in college. I don't know. Anyways, this is X, this is Y. So let's say we have, I guess we have it on there, or not. Text, 1000. No, let's do this easy. 1. 1. No, just 1. I guess. This is a weird editing drawing program. 1. What is going on? There it is. So we have an X of 1, a Y of 1. And basically, if you know vector math, the basics of vector math, you know if you have two vectors and you put them tip to tail, I think that's called, you can find out the resultant vector. I'm sure there's a more specific name for that, but it's basically connecting the very first tail to the very last tip. If you're kind of going from like, this is the first vector, second vector, first to last. That's basically our velocity in the world. But it's not just like a velocity of 1. And you can't just sum these up and say it's a velocity of 2. Basically what we have right here is a right triangle. And the Pythagorean theorem says that the length of hypotenuse is equal, well, not the length of it. Here we go. This is where it gets weird. The square of the hypotenuse is equal to the square of one side and plus the square of the other. So to write that out, they do x to the power 2 plus y to the power 2. This is basic like algebra, trigonometry stuff. Geometry is equal to, we could use z, just in this case. You know what? Let's use h. A lot of times you'll see it written as a squared plus b squared is equal to c squared. You'll see that a lot in like textbooks and stuff like that. But since we're using, in this case, x and y, and we use x, y, and z in Unreal, I'll just go with that. So this h is not actually just h, is basically our velocity. Let's do capital V. And this will be our velocity in the x, and this will be the velocity in the y. Let's make it lowercase v. I made it in my mind. Just to be consistent with units and stuff like that. So our velocity in the x direction squared plus our velocity in the y direction squared is equal to the velocity squared. So if we plug in our example where we have 1 squared plus 1 squared, that's going to equal velocity squared. You can see where this is going. 1 squared is just 1, so 1 plus 1 is equal to velocity squared, and then that's 2 is equal to our velocity squared. Lowercase v, not b, squared. So now to solve for velocity, you just take the square root. You know, so I don't know how to write this out. V square root. There we go. Square root of 2. Which this is equal to 1.66 something, I think. Let's just double check this just to see. Oh, it's not. It's 1.4. So that's going to be our velocity. So that's right here. So you can see there's not really like a linear translation between X and Y components into the final velocity. So what we're gonna do is, you know, instead of having like 1,000 in the Y direction and, you know, like 100 in the X direction, and trying to figure out how that, you know, the resultant vector is gonna look something like that, you know, that'll be our velocity. But trying to figure that out and then trying to scale it down and stuff like that is going to be kind of weird. So what we're going to do is we're going to get the normalized version where we say, instead of trying to figure out what V is, I mean, because we can figure out V pretty easily, we want to scale it down to V is equal to 1. So we know that our unit vector is going to be no bigger than a velocity of 1. So when we do that in here, we get that velocity is equal to 1, but we still get the same shape of the same ratio, I guess you would say, of like this is your X is 100, right? That's kind of hard to see, but so there's like a certain ratio between your Y length and your X length, and we want to scale these down pretty easily, right? So when we get the unit normal, these will be scaled down, but they'll be scaled down so that they're in the same ratios, and V will equal 1. And the important part of this is, since V is equal to 1, we know that whatever we multiply the unit normal vector by, we will get a V times it by, or 1 times it by whatever we multiply it by. So since we want a maximum of 2,000 for our velocity, I could just take the unit vector and multiply it by 2,000, and we'll get a vector that will not be any bigger than 2,000 absolutely, no matter what the X or Y or Z is. So let's actually do that. So we have the normalized vector. It's very easy to do, right? I was like showing you all that math and stuff like that. Computers make it really easy. So we have the normalized vector. Now we want to multiply it by our max vector, or our max velocity. Let's just put it right here. Not vector times vector. I was not paying attention. I want a scalar multiplication. Vector times float. I'm pretty sure I'm right with this. I think I mentioned before, yesterday I was going through some crazy movement vector math things I was trying to figure out, and I just cannot figure it out. So I might still be crazy from yesterday. But let's promote to variable, because I want to make this a variable now. It is time for it. So max velocity. It'll be a float. It'll be editable. The highest absolute velocity. I cannot spell velocity allowed. My phone is beeping at me. Okay, sorry about that. Slider range, obviously 0. Yeah. The unit normal will also take into effect negative values too, I think. I'm pretty sure about that. If not, that sucks. Then we'll figure something out. 0 on our value as well. And our default will be, I didn't like 2,000, so let's make it 3,000. That should be faster. Alright, so now we've multiplied our normal vector by our max velocity. We have now our intended clamped velocity. So now we should just be able to plug it in there. Let's bring this closer. Something like that. Straighten that connection. So let's close in, straighten. That looks better. This is pretty clean flow. Like that. Let's compile, let's save that. And now we should have in our, let me organize this a bit. Let's move the cubes into geometry again. So that cleans up our outliner. I clicked on Gecko Ball, so my computer has to freeze for a little bit. Don't worry if the stream crashes, I will be back. Come on. I really need to down res that ball. It's causing some problems, I think. Any second now. Huh. I think it's back up. I think it's back up. Hello? I don't think it's back up. No, it's not yet. Okay. Well, what else can we do? They'll set this as like level 1. Let's label this stuff real quick so I don't lose track of it. Level 2. I might do a lot of this level design. What is going on here? Level 3. What the heck? Yeah, I might do this off stream and then present it to you guys as a completed design document. But what can we do for level 3? I think level 3 might be a good time for risk, to give a little bit of risk. So now, no easy, large open areas. We're gonna have some holes to show what death looks like. So maybe I'm thinking maybe like a starting area like this. This is gonna be very Super Monkey Ball-esque level, and then a ramp right here, and then basically a larger platform up here where I don't want to make it too complex. I was thinking maybe we could have a bunch of small guys here, you know, like little holes here, but we could also you know, some pattern, you know, probably smaller pattern like this, or smaller pattern than this, and then we'd have our goal at the end here. But I was thinking like maybe you could open some holes up and close some holes based on like a global timer, but that might be a little bit too much for level 3. I think just having holes in the platform so it ends up looking kind of like just to kind of show you the side view. This will basically be the side view. You start out here, that's the player, the goal is up here, kind of like that, and then you have your holes going down here. So, you know, it's time to die basically in there. I gotta save this somewhere. We can go back to the Unreal editor to see if it has not crashed at all. I think my computer is taking a long time to think. Okay, so this is back up and running. So I'll open Office. Thanks again. What I wanted to do in here. There's something I want to do. Oh, our max velocity has now shown up here. 3,000. Is this ready to behave? No. What? Anyways. Maybe time to do a computer restart eventually. It's just not being responsive at all. Guess we don't need a calculator. That's probably hogging up so many resources. We definitely don't need that. Okay, now that's responding. I don't know why that is, of all things. Let's check out our maximum velocity limiter now. So on the top left we have our velocity, our absolute velocity in green. So now our movement will be capped at 3,000 even if we're moving diagonally. And now what is this about? Okay, never mind. Let me repossess. So if we're gonna go off forward and we're gonna jump off our little ramp here, our velocity is now clamped to about 3,000. No matter if we're falling, if I'm holding a direction while falling, it's still going at 3,000. So that's that. All right. So now we've got our character movement pretty much working. But my computer is not working. So I think we're going to wrap it up here. So we got our main character movement done. We just need to fine tune some things and stuff like that. But I think I want to move on to some of the level design. So I'm going to start working on my own time. First, I have to lower the res on my sphere so that my game doesn't completely freeze when it tries to render it. That's freaking nuts. Definitely need to do that. See, it finally responded. What the heck just happened? I clicked on my sky sphere. See, it freezes again. So, yeah, I just need to work on that. Get that out of the way so we can actually work on stuff. The movement is pretty good for now. But like I said, fine tuning. But yeah, I guess next time you'll see me, I will hopefully have a lot of levels to show off in terms of their design, not their actual building. Then I will hopefully turn them into actual built levels. So we'll see what that will look like. And I think that's all I have in mind, I guess, for now. But there are kind of background things that I need to start thinking about, like building the game logic, like, you know, like the game mode. Need to start thinking about doing the HUD and stuff like that. So off stream I might do some basic I guess prototyping and kind of mock-ups of UI items and well, UI items, UI flow, maybe menus and stuff like that. That might be a good place to start, like a third or fourth stream as well. But I would definitely like to. I'm excited for level making and level designing, and maybe have to go back and play Super Monkey Ball 1 and 2 to get some inspiration and totally copy those levels. No, I'll try not to make identical levels, but I want to take some inspiration from that, because that's the whole goal of this project, is to make a Super Monkey Ball clone. But I think we made some pretty good progress today. Get a character that moves pretty well. Our camera is okay. We just need to be able to control it. That'll be another stream. coming up. And then I will need to, in Blender, I will do another stream where I'm making the static meshes for the level blocks so that we can basically construct in building blocks like Legos our little maps. So hopefully that'll work out pretty well. I think it will. All right, well, thank you for coming out. If you have any like suggestions or recommendations or any like, you know, feature requests or anything like that, you know, let me know. You know, put a comment in or hit me up on Twitter. I'll look at that eventually. But yeah, I don't mind, you know, if people have like suggestions or anything like that, I'll take that into consideration. You know, people have like suggestions for maybe like, I don't know, like themes or skins, you know, or something like that, or characters, you know, go ahead and let me know. All right, well, again, thanks for coming out. I don't know like a schedule for all this, but I'll try to do kind of like afternoon, evening type of thing, at least in my time zone, so I can at least get kind of regular work done on this. You know, it may not be streamed if I'm doing something boring like just level design, not actually making the level. But I do want to do like Blender. I want to learn how to do some music making, also some, you know, basic 2D artwork for, you know, menus or texture working. I wouldn't mind streaming that, some of that stuff, if that's more exciting. So, all right, that sounds pretty good. All right, see you guys. Hopefully this turns out like a pretty good project for my first project and for your viewing pleasure. All right, bye guys, see ya.